Pumping gas is a routine task for drivers, but it's often seen as an unavoidable chore. The ever-changing gas prices add to the frustration, making the experience less than enjoyable. But while you're standing there, watching the numbers on the pump climb higher, have you ever paused to wonder how the gas pump actually works? How does it know when your tank is full and stop pumping to prevent overflow? The process behind pumping gas is straightforward, yet fascinating. To understand it fully, let's start by examining where the gas comes from before it even reaches the pump. Beneath the service pumps at every gas station, there are large storage tanks that house the gasoline. These tanks are usually buried underground and can hold thousands of gallons of fuel. Typically, a gas station will have 2 or 3 of these massive tanks, each designated for different grades of gasoline, such as regular, mid-grade, and premium, or for diesel fuel. The gasoline stored in these tanks doesn't just magically appear at the pump. It has to be brought up from these underground reservoirs. Since the tanks are below ground, gravity alone isn't enough to move the fuel to the dispenser. To overcome this, gas stations use pumps to draw the fuel up and into the dispenser where you fill your vehicle. Gas stations typically rely on one of 2 types of pumps to move gasoline from the underground storage tanks to the dispenser: submersible pumps and suction pumps. Submersible pumps are located directly within the underground storage tanks, submerged beneath the surface of the gasoline. They use a mechanism called an impeller, which is a propeller-like device, to move the fuel upward. The impeller has angled blades that rotate at high speeds, creating a centrifugal force that pushes the liquid upward. This action is similar to how a fan uses its blades to push air. The gasoline is propelled through a pipe and into the dispenser, ready for you to pump into your vehicle. In contrast, suction pumps operate on the principle of pressure differences. The pump itself is located above ground, usually within the dispenser. A pipe extends down into the gasoline tank. The pump's motor removes air from the pipe, reducing the air pressure inside it. As the air pressure in the pipe decreases, the higher external air pressure in the tank pushes the gasoline up the pipe and into the dispenser. This method is less common than submersible pumps, but is still used in some gas stations. Once the gas reaches the dispenser, it's ready to be pumped into your car. The process begins when you remove the pump handle from its cradle. This simple action triggers a switch that activates the pump, starting the flow of gasoline. But how does the pump know when to stop? The answer lies in a clever piece of engineering built into the nozzle itself: the nozzle and the Venturi effect. Inside the nozzle of the gas pump is a small pipe called a Venturi tube, named after the Italian physicist Giovanni Battista Venturi, who discovered the Venturi effect. This effect describes how fluid speeds up as it flows through a constricted section of pipe, creating a pressure difference. Here's how it works in the context of a gas pump. As the gasoline flows through the nozzle and into your car's tank, some of it also flows past the Venturi tube. The design of the tube causes the airflow inside it to accelerate, which creates a vacuum. This vacuum is used to keep the nozzle's handle open, allowing the gasoline to continue flowing. As the fuel level in your car's tank rises, it gets closer to the nozzle. Eventually, the rising gasoline covers the end of the Venturi tube. When this happens, the air flowing through the tube is blocked, breaking the vacuum that keeps the nozzle handle open. Without the vacuum, the handle snaps back, shutting off the flow of gasoline. This mechanism prevents overfilling and ensures that your tank doesn't overflow. Sometimes the pump may shut off before your tank is actually full. This can happen if the gasoline is flowing too quickly and causes a temporary backup in the fuel line. The fast-moving gasoline can create turbulence, leading to the Venturi tube being submerged prematurely. When this happens, the nozzle shuts off, even though there's still room in your tank. If you've ever experienced this, you may have noticed that pausing for a few seconds before resuming pumping usually solves the problem. This brief pause allows the gasoline in the line to settle, eliminating the turbulence and allowing the pump to accurately gauge when your tank is full. However, if you try to keep pumping without pausing, you risk causing a spill. The gasoline may overflow from your tank, wasting fuel and potentially damaging your vehicle's paint or the environment. It's always best to let the pump do its job and stop when it's supposed to. The process of pumping gas might seem mundane, but it's actually a marvel of modern engineering. From the underground storage tanks to the sophisticated mechanisms inside the nozzle, every part of the system is designed to ensure that you can safely and efficiently refuel your vehicle. So, the next time you find yourself at the gas station, take a moment to appreciate the complex process happening right before your eyes. Knowing how it all works might just make that necessary chore a little more interesting.
That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.